Yes, so certainly if you're looking for a field of research and you want to have a chance that that will go out into commercialization rather than simply get published in a journal, then you have to start by looking for the people in industry who've got the problems you might be able to solve. And for doing that, I guess you can tramp from door to door, or you can turn up to find someone who does that tramping from door to door for you. WaikatoLink at Waikato University is there to do that kind of thing. So if you say, I'm in this field, tell me the companies who are operate in that sphere, give me some of the problems, and it's always fairly easy to commercialize in that direction, but you've got to find a company who wants to do the kind of things you want to do. So you've got to find an industrial connection who's in your line, or you wind up working on something which you feel as if you ought to be paid for, and that's no good. That's not what a university should. That's not the game you should be in. You've got to enjoy what you're doing. You've got to want to see it go out. You've got to have some enthusiasm behind it, and so you need to find the right company who's going to have the same enthusiasm for the same invention. I often give my students something like a startup book to read. Most students want to run a company or start a company. I'm going to spin out is the golden aim, and some of them do actually. But there is certainly a point where research at a university wants to move out to a company. There's various things which we've progressed to the point where we get local companies involved in the production of something. When we want more than about 3 of them, it's time to find a company. You either spin out a company and start manufacturing them if you think there's enough of a market. Maybe you go to local companies and you get them to assemble something for you. We have various projects at various points where we get local companies involved. As I said, sometimes my students have started up, there's a couple of groups who've started up companies when they left. Those companies, like my first company, don't tend to fare all that well because you find there isn't enough market. But there's a pathway to come out of a university into commercialization. Our students are always enthusiastic about doing that. The place is pretty good about that. You have to deal with intellectual property. You have to handle it sensibly, protect it where you can, run with it in other circumstances. That's something this place does very well. It's small, it's integrated with the different departments, it's close with local manufacturers. It's a good environment for that. To get effective research done, you really need to have a critical mass. It's much more difficult if you're working by yourself. Working by yourself is more like a consultancy job. It's less fun. You want to be paid. But if you want to get some real momentum in a group where ideas are being bounced around and put out into the field, you want to collect students. And I discovered almost by accident that the ingredients to attract students, and now I have to refuse most of them who come to my door because I have more students wanting to work with me than I have capacity to handle. The first thing is you have to pitch the idea or the project with some enthusiasm, and you have to tell them it's going to be fun. You don't want to do a year or 3 years on something that's dead boring. So you've got to pitch it excitingly. And I discovered also that it's very effective to put it on a web page. I think they like to go back and read it a couple of times. They don't want to feel as if you're giving them a hard sell. But you say, if you're interested in this field, I have 2 or 3 projects. Here are the URLs. Feel free to read up on them. Come back, talk to me afterwards. That's worked a charm for me. An important part of commercializing something comes from you really wanting to see your baby out there. I get students who will come to me and they say, I really want to work on something that's going to be patentable and make a lot of money. And you actually don't want to take those students on because they're just, it's a business exercise and they're not there's no love of the technology. It has to start with the love of the technology. That's what Bill Hewlett loved what he did, and his ideas were loved by other people. He wasn't sitting there thinking, I'm going to make a multinational company out of this. He said, you know, if we've got something that's useful to people and it sells well, that's great. And that attitude is very, very important to something being seen through the distance. It's a long distance. You've got to love doing it, or you don't get from the start to the end. Okay, one of the projects which came to be an instrument that Agilent is selling was a project that I was told not to do 3 times. And we really knew that what we were working on was going to be useful. And it turns out, if you read the literature, that an enormous fraction of the successful projects coming out of Silicon Valley were what were called skunk works, which was something done under the table, unofficially, an idea cooked up behind people's backs or without proper funding. So it's almost as if the staff were siphoning resources off into something they shouldn't have been doing. And you know, in about 25% of the time, it turns out that it really was something you should have been doing, and it makes a bundle of money in the end. I worked on a pulse generator, a phase reference, which is now sold as a product, and it's a key element inside a nonlinear vector network analyzer. So there's a lot in developing an idea to commercialization which doesn't match the prevailing policy. It's something which the marketing department wouldn't have approved because nobody really knew they were going to use it. It was just a gut feeling on the part of some of the engineers involved that that was a really cool idea and we can't let that drop. It's too good, too elegant, too useful, and it really does turn out to be useful when you've finished. So there's a lot of pursuing that, and you're very lucky if that gets to market. You will often produce something that's beautiful but doesn't sell in a big way. The examples of skunk works that people have loved but they nearly lost their shirt over, but it was still an extremely good piece of engineering. It's just something that failed to cross the chasm to commercialization. You know, there's all sorts of things that I invent that I think that's terribly neat, and a couple of people will say, we saw you did that work, it's wonderful, but I'm never gonna make money out of it because there's just not enough people who want to do that to make it worthwhile. You know, like you could invent a parachute for a motorbike, but you know, not enough motorbikes need parachutes. It's never going to fly. It might be a brilliant parachute. Good students, good graduates arise when you have good teaching and when you have student engagement, and bearing in mind that I think engineering should be fun, we try to get as much fun and enthusiasm in to engage the students. As an example, we have a final year program on mechatronics. We teach the students to execute data communications projects. We have them talk to digital model trains and they drive around a track. We've also started playing with digital slot cars. If you haven't seen these things before, they work like ordinary slot cars, except you have lane changes so you can overtake your competitors. And we have a project to get a computer to drive the slot car better than a human can. And the slot cars are a remarkably good model of real cars, except for the steering part. Round we go. Come back, come back. There you go. Whoa. And we'll see if we can land him. Oh, oh, oh. Whoa. Close. Even tells you when you're crashing. You know, gives you a picture of what you're doing on your latest PDA. Isn't technology marvellous?
We can weld together large structures. We provide all of the students with access to lathes, milling machines, tools. We have small workshops up in electrical engineering where the students can go and do work quickly. That's a big plus on a department. You don't spend time waiting for things, you can get hands-on right away.